Hello everyone, Assalamu alaikum. I am Muhammad Wahidur Rahman Araf. We are working on the project 2, which is PID implemented line follower robot. Now we have to build an environment for the project. At first, we built a floor with walls surrounding it. Then we add directional light and we fix the parameters of this light. We add collision. First we make the object transform into solid, then we go to bounding object, then we add collision to that object so that robot doesn't fall from the floor. Now we add physics on each object. Then we add friction. We go to the world info and select contact properties, then add a node contact properties. There in the parameter we change the coulomb function, which is by default 1. Then to make a robot, we first added a geometric shaped box and then fixed its parameters, then added physics. After that, from its children, we add hinge joint so that we can have a rotary or linear motion and its joint parameters. We created a wheel and fixed its coordinates so that wheel placement gets perfectly, and then again add a hinge joint for other wheel and replicate the wheel in the other side. We actually created 3 wheels, but then in the code we worked with only 2 wheels. Now from tinker.org we took line track as a 3D object placed it in the floor. Then we placed it in the floor. Then we added 5 distance sensors. Those sensors are infrared type. These sensors can sense the 3D track in the floor.
For our project, we have used Python to build up the controller. So first of all, we have imported the robot library from this controller module. After that, we have created a robot instance here, and this time step helps to operate a loop that will be maintained by the robot during its movement. Here we have stored these sensor names in this array. These are the same names we have used for our sensors here. We have used the infrared type for these sensors. Since we are using a black root, these infrared sensors will help the robot to move forward easily. Next, we have created a temporary list that has been initialized by 0, and the length of this list will be the same as this array. This list will be used to store the values of the distance sensors. Then we have created another list, and in this loop, ds.append robot.getDeviceName. Here name is basically the strings we have used as the names for our sensors. So if we get any devices or sensors with these names for this robot, then those actual devices or sensors will be added to this list. Then we have used the same process as before to form this wheels list. In this loop, this piece of code ensures the 360-degree rotation of the wheels, and this has been used to initialize the velocity of every added wheel by 0.0. So this is basically the first half of the process to make this project work. And another important part is the PID controller.
PID control stands for proportional, integral, and derived feedback. A PID controller is a control loop feedback mechanism that calculates the difference between a desired set point and the actual output from a process and uses the result to apply a correction to the process. In our code, here for PID values, I have taken some variable. For error, I have taken 2 variables as previous error and set their initial value as 0. For I and balance, I have also set their previous initial value as 0. For calculating PID, we need KP, KI, and KD. By doing trial error, we get some value of KP, KI, and KD, which will help our robot to follow the line. After that, we have to use calculate PID. In this calculate PID method, I have set previous error I, KP, KD, KI balance as our global variable. Here, Proportional is equal to error. An integral is the summation of previous integral and error. Derive is the difference between error and previous error. Here balance is the main PID value. I have taken this variable name for our PID. To calculate the value of balance, I have to multiply proportional to Kp, integral to Ki, and d to Kd. After that, I have to add them all. After that, I have to shift the value of error to our previous error and return the value of balance, which is our main PID value.
Well, this is the main loop where the robot actually runs. At first, we have initialized the loop so that it can run infinite times. We have printed to check if the robot is actually running or not. And then we have stored the value from the distance sensors to a temporary list where and this list is used to check this if else. Here we have used a threshold 800. We have found that 800 is a suitable position by trial and error. And in this section, this actually checking if the robot is left or right to the line. If the robot is left to the line, it needs to move to right, and if it's right to the line, and it needs to move to the left. So this part is doing here. If the value is positive, that means the robot is actually on the righter side, and if the value is negative, that means the robot is on the lefter side. And if the value ERR value is 0, that means all the 5 sensors are facing the line. Here we have printed the error just to check, and then calculated the PID. As the error is a global variable, so the method PID will find that here, and then just calculate the balance, and from the balance we can set speed, and while setting the speed we have used 1.5 plus and minus 50 times the balance. We have found that if we multiply the PID value, the balance 50 times, we can get a suitable result, and the robot moves directly on the line. If I run the robot, we can see the robot is actually moving towards the line. When the robot is going too much right or too much left, it just turning itself towards the opposite. If I fast forward it, we can see clearly that this robot follows the line. Thank you so much.